So we are recording. Yes. So what are the key features of this model? Like UML, it divides the design space into different dimensions. So different views or different design dimensions for a web application, which are content, navigation, interaction, operation, and presentation. So the main focus will be about content, navigation, interaction, and a little transactionalities that change the state of the system, that change the data of the system, except the data about the navigation state. So in any application, there is a navigation state which describe where the user is. And in some cases, in more sophisticated cases, what is the path that the user traversed, the sequence of steps. We assume that this is the only modification that takes place in the system. So we do not model transaction on or forms or things that change the state of the system. When I fill a form, I'm changing the state of the system because I add the new data. When I make a transaction, I change the state of the system because an item that I buy or I reserve is not more available yet. So any operation for us, anything that changes the state of the system, except navigation, and we do not model it. We model the dimension of content, the dimension of navigation interaction, and partially the dimension of presentation. So the model, since there are different views, we have a layer model. So we have different submodels, these three submodels that model in a somehow overlapping way the different aspects. And the other important point, which I would like to stress here, and please remember, because that is the source of most mistake that you students do in your reporting, in your use of the model, that IDM focuses on in the large features only. So the detailed feature must be described using different models. So if you want to describe all the details about a web application, one model is not enough. And IDM model in particular is not enough. What we do is model only content in the large, navigation and omitting interaction in the large with the model operation, and with design model in the large features for presentation too. So it's easier to say what you don't model with IDM. We do not model how to interact with animation. So the fine-grained interaction. For us, interaction is basically navigational interaction, moving from one piece of content to another piece of content. We do not describe the detailed data. That is another important point. So when we say in a website of a university, there will be courses, teachers, events, and so on. But we don't say the detailed data. We don't say that a teacher is this or a student is described by name, surname, personal code, academic classification, and so on. We say we have courses and we have teachers. So we do not, or for a course, we don't say the course is a title, a starting and ending day, a number of credits. We remain at a higher level. These data, the detailed data associated to these macro elements that we model in IDM, will be described using a different model, typically an entity relationship model. In the same vein, we do not describe, you do not describe using IDM, the detailed layout properties. We just say, okay, this page contains this element. How these elements are visually arranged on the screen, what are the fonts, what are the graphic decoration, what are all the detailed visual effects that Julia discussed last week. They are not in the scope of IDM. you will have to report it in your, will have to report your design solutions for the layout in your documentation for the project, but using approaches that are different from IDM as it is presented here. So, as I mentioned, there are 3 submodels, and each submodel is the input for the following one. So C-IDM is the input from L-IDM, and L-IDM is the input for P-IDM. Okay, let's consider the different design dimensions. For content design, what do I use? I mainly use C-IDM, which is also called content DM, but in the transition from the content to navigation, you use L-IDM. So the main submodel is C-IDM that allow you to model content. And then in order to model navigation feature, you mainly have PIDM, and PIDM, which stands for page IDM, is where you really model the actual navigation structures. But in between, there is an intermediate technical path, which is called a technical modeling step, which is done with LIDM. PIDM model the navigation aspects, which are also related to presentation in terms to page organization. Anyway, in content design, you design what can be said. What is the content of this conversation between the human and the system? How the different subjects of the conversation are internally organized, how they are mutually related, and how they are grouped. The basic ingredients. Then during navigation design, you move towards what was mentioned before, information architecture. You're trying to figure out how this, starting from these building blocks, which are the basic subjects of my website and the basic relationship that I want to exploit and the basic way I want to group them, I move to a next step in which I reflect and take decision about high-level page structures and navigation, and that is done with PIDM, going through this intermediate step, technical step, which is LIDM. And then these elements are further refined when you do presentation design, because you cannot do navigation if you don't have the concept of page. You cannot have the concept of page if you don't have navigation. So for the decision taken IDM was to try to imagine some basic navigation concept first, and then to refine them through presentation. So the subject, the remaining of this lesson, we will focus on C-IDM, which again answer these questions. These are the design questions that are answered using C-IDM. What should be said in this application? What are the types of subject addressed during the conversation? What are the single subjects that you speak about? What are the relevant changes of subject to be supported? And what are the possible different ways to group the dialogue subjects? That are the questions that your starting question in your process. And so you have to take decision about this question. And how do you describe your decision? You use these basic primitives. So in order to answer what should be said, you have the concept of topic, kind of topic, which sometimes is called multiple topic or type of topic. Oh, sorry, topic, forgot. When you, in order to describe your decision about the domain-specific relevant relationship about topics, which are the changes of subject. When I speak about a painting and ask what about the author of this painting, I'm changing subject. So in order to model this change of subject, we have the concept of relevant relationship or semantic relationship. And then in order to answer the question, to describe our decision, to answer the question, how do I organize dialogue contents in meaningful groups? I have the concept of group of topics, nested group, and multiple group. So we will go through this concept step by step, also referring to the National Gallery of Washington to exemplify the various concepts. We have concept here and we have notation. These are the notations for topic, for kind of topic or multiple topic, for relevant relationship, for group of topics, and for multiple, sometimes called parametric groups. So you don't have many notation. Basically, as a general rule, when you have double line, like here. Okay, well, when you have a single line, like, okay, so let me start. When you have double line, like in this case, or in this case, this renders the idea of multiplicity of many things. When you have a single line, the idea is that I have just this. So the concept of topic, let me just go. Okay, let's exemplify this these primitives one by one in a toy example, which is the following. Imagine that you want to do a website multimedia guide, or better website, for a temporary exhibition about Edvard Munch prints hosted at the State Museum of Berlin. Very concrete case. The website mainly aims at presenting the temporary exhibition and is going to be used before and after the visit at home or at the museum entrance. So it's the classical website to prepare your visit, to search if you want while you're waiting for tickets or when you're going back. So let's see what are the example of topic. When you say the museum, this is a topic. When I say the exhibition, this is a topic. When I say life of Edvard Munch, this is a topic. Why this is so what a topic is? Something unique. You have just one individual like this. How many museums do we have for this exhibition? One, you're hosted in that museum. How many exhibitions you have is just that exhibition. How many authors you have for whom you want to describe the life? Edvard Munch, not only. So notice that being a topic, like these ones, is a property that depends on the application domain. If you and on the kind of the website that you want to do to create, because assume that you want to create a website with all exhibition at the Berlin State Museum of Berlin. The museum is one, but you have many exhibitions for probably many artists. So the exhibition and the artists become not topics, but something else, because you have multiple instances. Even worse, if you create a website for all museums in Berlin, even the museums is not a topic anymore, but it becomes something else. And this something else is multiple topics or kind of topics or type of topic. Here you model a class, you model a category. For example, print. Okay, by convention the category use singular and not plural. So we say print and not prints. Or we talk about technique. There are many techniques for the different prints. And so dry points is, so if you have technique, which is a kind of topic, a specific technique, such as dry point, is an example or an instance of technique. So we move from single elements, topic, to types, to sets of arguments, of subject, of themes that have similar characteristics. And then the third concept is relevant relationship, which models domain-dependent relationship from a print, the relationship between a print and the techniques, the relationship between a teacher and a course, between a painting and a room where it is exhibited. So it models a relevant relationship between the subject of your discourse with in terms of user discourse with the system. Typically, relevant relationships are symmetric. So this is this happens in 99% of the cases. So when something has a relationship with something else, that something else has an inverse relationship for that topic. And the relationship are described by arrows, like in this case. So you have a print, which is a kind of topic, technique is a kind of topic, and made with is a relationship. As I mentioned, typically these arrows are bilateral. So this is one relationship and the other one holds. So here I have represented just one direction. In the application, typically there will be also the inverse one. So it's important to notice that defining relevant relationship, like defining topics and kind of topics, is an arbitrary design decision. It's a decision about what you want to model, what you want to represent, what you want to speak about in the application, what you want to represent of the real world, what are the relevant aspects that you want the user to exploit. And in general, you can have that there are more than one relevant relationship between two kind of topics. For example, artworks can be related to painters because they are painted by given painters, or they have inspired given painters. It's up to you to decide which are the relevant relationships that you want to model and therefore implement in your system. You can also have a relevant relationship between topics of the same kind. So artwork can inspire other artworks, or can be located close to other artworks, or can be similar to other artworks. So nothing prevents having semantic relation between contents of the same kind of topic. And so far you could say, okay, it's very similar to the entity relationship model. What is new? Maybe at this stage, well, what is new are the other parts of the model. But at this stage, the main concept that characterize IDM with respect to the entity relationship model and other model is the concept of group of topic. Well, the other main distinction is that IDM is more in the large with respect to other model, but certainly beside the level of abstraction that IDM is in the large, there is a new primitive that is not explicit in other model, which is group of topic. Basically, what IDM says is that we want to have a groups of subject, group of content as first order citizen. We want to make we want a designer make explicit decision on how to group things. You know what the alternative is? A radical alternative to having explicit definition of group of topics. The alternative is make a search, provide a search engine guide the user with some parameter, and every group is basically dynamically created with a query. The designer does not make any explicit decision about how to group things. It tells the user, here are the parameter, search, group as you like. With IDM, we do not model search, only in a very soft way, without calling it a search. But in IDM, we say it's really important that you, designer, pre-package for the user what are the main sets, the main groupings, the main aggregation of topics, of subject that the user might need. So it forces you to think about what are the group that the user would like. So a group of topic is, in general, a set of possible subjects for your conversation. Typically is very often the starting point of a dialogue. When you go to a website, of a university, you probably first look at the list of master program. You start from groups, and then you get into the detail of each specific item of interest. Also, groups, give you, it's easier to speak about groups than to speak about individual items. So when you describe the group of an application, you're providing a high-level view of the application that helps user to understand what the application is about. And designing group also helps user to locate the set of access content, particularly if compared with search, which is a way for the user to express one or more parameters. And you don't know what this parameter will take out. You don't know if the engine is implemented to search for them. You are pre-digesting for the user possible classification, possible ways of looking at things. So these are two examples of groups. The top, again, in this Munch application website, the top 10 masterpieces. This is a group of what? Of prints that are considered, is the characterizing feature of this piece, of these prints, that they are masterpieces, and the curator consider them among the top 10. Another more obvious example of group is the group of all things of the same kind, so all prints. The notation, as I mentioned, is a diamond, an arrow to say the kind of things that you are grouping, and the thing that you are grouping. So in this case, all print is a group that collects prints. There are various reasons why you want to group things and various criteria to group things. Then we see here. So you can do something, you can group something by objective criteria, such as all prints created using dry point technique. This is an objective criteria. Or sorry, subjective characteristics, such as the museum's curator favorite prints. That is subjective, is in the curator mind. You can group things because they are relevant to some activities, such as if you have a food website, you can say food for a romantic dinner, food for Christmas Eve. So you think of all items, of all topics that are relevant for what the user is doing or would like to do. Or another typical classification criteria is to group things by user profiles. So for example, you can say we have bachelor students and we want to have all courses for bachelor students. Or also for marketing reasons. So you want to have a promotion, and in an e-commerce website, you collect of the product under promotion, under cost products. It's a marketing operation. You can put together fish, meat, cheese, and soap. This could be in promotion. Let me just suspend and ask for some questions. Everything clear so far? Okay. There were some very good questions. So, can it be seen as a filter parameter? Well, probably it's a problem. There is an issue of formulation here, but and we will go more in depth when we will discuss about multiple group of topic. But yes, there is. Okay, you can have a filter parameter, so you can say let's make the group of all novels, novel books. So filter by genre, by type, by a specific feature, by art, by literary category. So very often you have some filter parameter in mind, and the group is created according to that filter parameter. But conceptual is a set of things that share a common feature, being a novel, being adventure book. Okay. What is the difference between group of topic and type of topic? That is another very smart question. Okay, let me make a premise. In mathematics, you might be aware of the fact that being a set defines a relationship, all things in that set. So there is a sort of analogy or duality between set and relationship. So when you say, when we define a group of topics, I can say, okay, they all, by the very fact that they belong to this group, they are a type. Like, let's consider the group of people in this chart. We're somehow different, but we can say, okay, we are a group and we are a type, which is the type defined by those participating to this session now. So there is a sort of duality between these two concepts, and it is an arbitrary, there is an arbitrary decision what becomes a type of topic and what becomes a group. In general, when in general, when you define a type of topic, this is a sort of, it's a classification that correspond to understandable types in everyday life. Example, in Monte Rosa case. In Monte Rosa case, which is a sort of mess for some aspect, and this is one of the reasons why I ask you to evaluate it. You can have the types are could be the mounting locations, or the activities, or other examples. So in a mounting area, you have activities, you have location, you have slopes. So these can be types, regardless of the way you group them. Then you can say my top slope, or my top activities. In that case, of course, it can be considered as a type, but is less obvious in a sense. So, for example, when you group things by specific parameters, all novels, that can be a group, or that can be a type, a kind of group. It depends on you, because of course, all novels share the property of being a book and being novels. So it can be a subtype. As usual, the decision of giving a name, or another name to something, it's what you want to convey. The idea is that kind of topic are the basic ingredients, and no one would discuss that these are relevant, these are important. Groups are somehow more flexible. You can change at any time. So there are sort of second step design decision. Another question is, in the example, could a group of topics be called masterpieces instead of prints? You know, yes, you could. I mean, it's not a matter of naming, it's a matter of concept. not all prints are masterpieces. Not all masterpieces typically characterize something exceptional. So from a design perspective, also from a communication perspective, it's better to distinguish between prints that are objective stuff, something that has been printed with a given print technique, with respect to masterpieces, that is, I mentioned also the example, is a more subjective decision of what is a masterpiece. The types of element in the model represent very similar things. Maybe Chiara, if you could clarify this question by types of elements, it would be helpful for me to answer. So while Chiara clarifies her question to make it more explicit to me. Oh, okay, there is someone asking to get the control. Could you please ask? Could you please ask the control again? The student who asked me for getting the control. I was answering and I was thinking of giving him the control later. Okay, Chiara said, like in the last question, okay, like multiple, we will come to multiple parametric group in a moment. Okay. And I hope that I've answered the question about group of topics versus kind of topic. No one is going to ask again Okay, so here is an issue that we discussed briefly here, and we will discuss more in depth tomorrow. And this is the concept of nested group and multiple or parametric group. Nested group is basically the idea of groups which are sets whose members are other group, such as you can say, okay, I want to make the mother of our group prints, and I want to say, okay, I want to include all prints in alphabetic order and the top 10 masterpieces. In this case, prints is a nested group because its members are other groups. And so far, no problem. Just to say that groups do not group necessarily only topics and kind of topics. They can also have a membership relationship with other group. And then we have the issue of a multiple or parametric group. And basically are the ideas those of group type. The idea of type is I describe a bunch of things, not a single thing. So prints on a theme X, prints with a theme X, with X being a parameter, is a way to describe in one shot, in a very concise way, many groups. Which groups? The groups of prints that are collected according to a specific criteria, which is their theme. So prints about love, prints about death, prints about nature, prints about cities. Okay, so you don't want to represent each of them individually. You said, okay, I know that I will have many groups. These groups are made of prints, and these prints are grouped according to this criterion. They have the same theme. Okay, so it's a way to describe groups that have similar characteristics. Instead of listing each of them separately, you have one single specification to capture all possible instances. So here we have again the duality. We have topics and kind of member. And let me go up. We have topic, something which is unique, and multiple topic or kind of topic, class, categories of possible subject. In the same way, you can have a single groups that for which you have just one instance. You have only that group, and multiple parametric group. They are called parametric because typically they differ because of one or more parameter. And what is important about multiple parametric group is that they're typically, when you have a multiple group like this one, prints of team X, you typically need to group somehow them, to put them in a container, which is another group. So when you have multiple things, you group them together into a high-level group. So you have to imagine that groups are like baskets, like boxes. You have boxes of prints or boxes of items that have something in common. And so all boxes, imagine for other product, boxes of equipment, boxes of books, boxes of food, and then you have multiple of them. You have multiple types of food, multiple type of equipment, multiple type of other stuff. But all these multiple things need to be wrapped and aggregated into a high-level group. And the results, if you have a nested situation, which you have the various teams for the print, and then you have multiple groups, each one grouping prints of a given theme. Now, the typical situation is that you, designer, start with defining a multiple group, and then you aggregate this multiple group into a larger container, which contains all instances of this multiple group. Here is another example. Question. Let's go to the question. Would parametric group be similar to the mechanism of search and filter? Okay, now let me just go up to Chiara. Like the last question, group of topics also multiple parametric group. They all represent group of things. Yes, as I mentioned, groups represent group by definition. Kind of topics, in a sense, group. One main difference could be that groups are defined after, because they are more arbitrary. So when you define that, you're describing consider the project that you have for the exam about a voluntary association. The first thing you have to reason about is, what should I say in this website? I want to speak about activities, probably to speak about people, maybe about events. That is the starting point. So you define three kind of topics: people, events, and activities. And then you say, okay, but I mean, it's not just a flat word. I want to facilitate the access for the user to some specific to this content. So I will group events by date. I will group people by role. I will group activities maybe by user category, if I make activity for children, for adults, for the elderly. Okay, so in a sense, from a mathematical viewpoint, these are all sets. From a design process viewpoint, kind of topics come before. They are invariant. So when you have decided that you have to represent in your website people, activities, and events, that's all. And in a second step of the design process, you said, okay, I want to organize them in group this way. And the groups, since topics and kind of topics are the building block, the groups are more dynamic. The group are more flexible. The group can be changed in an easier way. And this is related to the mechanism of filter. So groups can be in what is called can be created algorithmically in some cases, if they are objective, that they follow objective criteria. So you represent it in your designs, but from an implementation viewpoint. So creating them through a search, through a filter, through a query database, that is an implementation issue. But certainly, if you take a group of the website is still works. It is something valid. But if you take an entire kind of topic, remove completely activities, not like removing a group of peoples by role. So it's just a matter of priority, or it's a kind of chicken egg problem. What comes first? The idea is that first you define your topics, your unique individuals, and your basic classes, and then manage and define the multiple ways to reorganize them. Could we say that groups are used to differentiate kind of topics? Not sure I understand this question. Let me try with the second one. And there exists inherent overlap relationship between groups and topics. Again, there is a duality because every set is a group, every group is a set. So it's just a matter of temporal moment in which you define the different things. So please initially define the universe of your discourse in terms of, we will speak about activities in our voluntary association website. We will speak about people, activities, and events. That is the starting point. Then let's group things in different ways. So, of course, by the way, there is an obvious overlap of contents in the sense that groups are made of topics or instances of kind of topics, but they are higher level structure. Following this parallelism, can we represent topics as item, kind of topic as labels that can be associated to multiple items, and group as boxes in which to put everything? Okay, I think in this metaphor, groups as boxing to put where to put any topic or other boxes, it's okay. Topic as items, again, is a terminological debate if the word topic is better than item. Kind of topic as labels, but kind of topic, yes, these are names for items that that can exist in multiple individuals. Okay, kind of topic is, yes, it's a label, but any label has a concept, and the concept is things, subject, content that have some similar characteristics. Like data types in programming. I mean, real, when you say real or float or integer. Integer is a label for what? For a set of numbers that have a very specific set of characteristics. Being an integer means that you have given operation and not others, and so on and so forth. Okay, I mean, the debate, we could continue the debate about, but it's nice to have this debate, but imagine that you really need to be, it's an opportunistic strategic process. Remember, it's we're trying to answer this question: what should be said? What are the type of subject addressed during the conversation? What are the change of subject due to relationship that we want to explore? How do we aggregate things to facilitate the discussion? Imagine a conversation. When at the beginning of this lecture, I said, okay, today we will talk about this subject. I am grouping, I'm starting my conversation by grouping all the specific topics that I will say, that I was going to say at the beginning of the lecture. So very often a conversation starts with a group. This is an arbitrary group that I have created concerning the main, what I consider the main topics on my lessons today. If I had a link here, which I don't have, but I could have had a link and click here and go directly to that specific topic, which is one of the, if you remember, there are many pages about what and why, many, 3 actually. Huh? Okay, well, that is the idea, that groups in some cases are the starting point. Conclude. Just a quick, groups are the most the elements which initially give more trouble to students to understand, not because they're stupid, because it's a sort of, it sounds like an ambiguous definition, but it's again, the distinction between kind of topic and group of topic is opportunistic. Group of topic are something that you put together in a package, starting from something that has been previously defined. What you define first is topics and kind of topics, and then you create these bags that are groups. Relevant relationship, we already said something. So it's model how things are related. Here again, we have an opportunistic decision about, we're not modeling the world like in the, I mean, to do AI application, you need to have as many data as possible about everything in the world, and you need to model all possible relationship between things in the world. Here, you just model relevant relation, something that you think is relevant for your user. And again, it's an opportunistic, opportunistic decision that you take. Okay, no, okay. No time for mentioning cardinality, but if to answer a question. Okay, no question. Okay, so we just have one minute. I would like to remind you that to go together, we will continue. I will start posting this initial set of slides for you to revise. I would like to say that any question that you may have, you can send me, CC, the other teaching assistant, a mail message with subject hypermedia question. I will take your question, put in the frequently asked question file that you should have received a message on beep. So any question will be not replied by email, but replied on the FAQ so that you can share it. So if you have any question, feel free to write to me and I will answer in this frequently asked question file on a Google Doc. There is anything specific, any specific question that you want to urgently answer? Otherwise, we have been asked by our dean to stop lessons exactly at the quarter and to start exactly at 12:30. Okay, apologize again for the mess of this of today. Okay. Bye-bye then. Should we start making all the diagrams of the project? That is a good point. Is no. Next week, because I will give you some more some detailed specifications. So if you want to know next week, as an exercise, yes, but not for the purpose of the exam documentation. And the reason why is that I will give you some specification. You'll not be asked to make a totally free diagram. We will give you some constraints, so some topics, some kind of topics, some groups, and some semantic relationship. Okay. Thank you. Have a nice day and see you tomorrow. Thank you for your patience too. For being patient.